Thank you. So thank you for joining the session today. We're going to talk about always-on troubleshooting improvements for SQL Server 2012 Service Pack 3 and SQL Server 2014 Service Pack 2, which is going to be available very soon. So I'm just going to quickly introduce myself before I get into my session. So I work as a program manager on the SQL Server product group. The team that I work on is called the Tiger Team. Our Twitter handle is MS SQL Tiger. So all the enhancements that we're doing for the SQL servers that you're running in your current environments, you would see them on our blog, which is aka MS SQL Server Team, or you would learn about them through the service pack and cumulative update announcements that we do on our SQL Server Release Services blog. I've been a speaker at various events. I currently work on the HADR and the replication technologies on SQL Server. So let me quickly set the agenda for what we're going to be talking about in the next 1 hour. So we'll talk about always-on availability groups. We heard a lot of feedback from customers that we have talked to in the recent past. Mainly around how do you troubleshoot failovers, how do you troubleshoot when there's a timeout between 2 different replicas, how do you troubleshoot any kind of failures that have happened in the availability group related to maybe network issues, maybe performance issues. And the second biggest feedback that we have had is, what about latency? We have latency. We don't know what's happening. Is it the primary replica? Is it the secondary replica? Or is it the network? So how do you track down what exactly within the topology is causing a issue? And if it's an issue, how do we find out what exactly is the latency and how do we go about troubleshooting that? So a lot of this feedback resulted in the improvements that we're going to talk about today. So we shipped in SQL Server 2012 Service Pack 3, and we're going to ship in 2014 Service Pack 2 improvements which help you troubleshoot 2 things, latency and timeouts. Some of the existing diagnostics that were available in always-on availability group environments is enhanced. Some of it we piggyback on top of, and some of them are new. So let's talk about what we shipped. So the first scenario that I'm going to talk about is availability group lease timeout. Now, what's a lease timeout? So whenever you have a issue with your availability group and it fails over, or the connection between the primary and the secondary or between any secondary replica gets disconnected, or the cluster is unable to figure out what the health of the availability group is, it all starts with a lease timeout. So the lease is nothing but a check between the service and the availability group resource to determine what the state of the availability group is. And there's a health check that happens, and if that health check doesn't return the necessary healthy parameters back to the SQL Server, doesn't return the necessary healthy parameters back to the cluster, a failover is initiated. But before that, there always has to be a connection made to check if the connection is actually alive. And if you have worked with clusters in the past, you would know what the is live check is. So this is, think of the lease timeout as a ping to your availability group to find out what the health is. And before it finds out the health, it needs to check if it's alive. So normally when a lease timeout happens, investigation does take time because you have to go through multiple logs, which is cluster logs from all the replicas. You have to go through the error logs from all the replicas, the Windows event logs from all the replicas, and the extended event traces that run on the server. So instead of taking time to collate all those logs and build a picture together, what we did was we introduced improvements in the extended events. And this is one extended event which basically polls every 5 seconds. So every time a lease poll happens to check if the lease is valid or not, an extended event with this name gets fired. The lease renewal should fire every 5 seconds. And if you're capturing that, it can be quite a chatty event. But if you have an issue happening on the server where you think the lease times out very, very frequently, you would want to have this event turned on with a rollover capability, which I'll talk about in my demo. Now the other one is the availability group lease expired. This has been enhanced to give you additional information. This is already present in the AlwaysOn extended event session, which runs on every instance that has an availability group configured by default. So whenever the lease expires, you get this event fired into that extended event trace, and you can open up the extended event trace in Management Studio, and you would be able to see how the what was the timeout, how long did it take to come back up, and when it actually expire. And based on that, you could then go look at additional information that is also available in a SQL Server instance to figure out if there were any issues during that time. So where is this available? As I said, 2012 Service Pack 3, it's already shipped, and in the next Service Pack for 2014, we will have this available. So the next big topic that we hear from most customers that use availability groups is tracking down latency. Now again, whenever you have latency, you have to do multiple things. You have to capture data from the primary replica, you have to capture data from the secondary replica, and you have to capture data over the network. Comparing all of that together tells you where exactly within the topology the time is being taken. So think of an insert that's happening on the primary replica, and if you are running in synchronous mode, which is one of the operating modes available in an availability group, you would then need to ensure that the data moves from the query executes on the primary, which means a log record is put into the SQL Server transaction log. From the transaction log, the log stream is picked up by the availability group transport layer, which takes the log stream, compresses it, sends it over the wire. It goes over to the secondary replica. If you have more than one secondary replica, which is also running in synchronous mode, it would go over to the second synchronous replica. And once the log record has been decompressed, processed by the secondary replica, has been written to the transaction log, because we follow a write-ahead logging protocol, and your operating mode is synchronous, it has to be put into the transaction log. And then an acknowledgement is sent back again over the wire. The primary replica receives this acknowledgement and says, oh, I'm done, because the secondary replicas have managed to commit the transaction. If you were in asynchronous mode, the only job of the transport layer at that point would be to push it over to the secondary replicas as and when time permits and as and when resources are available. There is a workflow that determines how many packets get pushed over to the secondary replica. We refer to as that flow control. So if there is no throttling that's taking place, data moves between your primary and secondary replica smoothly. Now, if there's a latency, what you would need to do is you would probably need to set up network traces on both sides and trace those network packets along. So what we have done is we have brought that network packet tracking capability within SQL Server through extended events and Perfmon counters. So instead of getting another root cause analysis investigation, which takes time, what we have done is we have introduced all these new extended events, which gives you the capability to track down where the time is being spent. The common theme between all these extended events would be the time taken, and I will show you which field within the extended event gives you the time. There's a common field, and all these extended events provide one phase or give you insights into how much time that particular phase took. For example, if you look at the HADR log block compression event, that basically tells you how much time did it take to compress the log block on the primary replica. If you look at the HADR log block decompression, it tells you how much time it took to decompress the log block on the secondary replica. If you look at HADR send harden LSN message, it tells you how much time did it take to harden the LSN. And receive harden is how much time it takes to receive messages to harden. So each of these extended events signify one phase of the always-on log stream transport layer, which I talked about earlier. So with all of these events together, you will be able to paint a picture of where the actual latency is and where the issue is within your topology so that you can go troubleshoot that particular component. Now, if you talk about the issues, what kind of issues this would tell you. So if you find that it's taking time to send messages from the primary replica to the secondary replica, then you know that there is a chance that there might be something amiss on the network and you need to perform network troubleshooting. If you know that there is a high amount of time being spent on performing the commit on the secondary replica, then you need to check if the secondary replica instance is having a resource-related issue, maybe I/O, memory, or CPU. If the primary replica is taking time to send the message across, then we need to check on the primary replica if there is a resource-related issue. So the time taken to narrow down where you need to focus your troubleshooting efforts gets reduced heavily by these new extended events. We've also added a few Perfmon counters, which I will talk about shortly during the demo. That would also tell you what kind of issues you can just track down by running very minimal amount of diagnostics on your production environments. So again, this improvement is available in SQL Server 2012 Service Pack 3 and in the upcoming SQL Server 2014 Service Pack 2. So let's go ahead and look at the demos. I specifically did not want to spend a lot of time on slides. I just want to walk through what kind of events are available and what kind of capabilities would you put your hands on when you start using these events in your production environments.
Hey Amit, we had one quick question. Are these features all going to be included in 2016 GA, or are we going to expect an update later to include these?
Great question. So these features are not available in the RTM release of SQL Server 2016. You would expect these features to be available in SQL Server 2016 in an upcoming update.
Okay, great. Thanks.
So let me switch over to my virtual machine running on Azure, which has an availability group configured. So first, let's look at the lease timeout. So as I mentioned, every SQL Server instance that has an availability group running always has an always-on health event being run. So let's look at that first. So what this event does is it gives you the capability of tracking down multiple things. So I'm going to quickly go ahead and switch over to configure. For example, you get to see when an always-on DDL executed. We were talking about the always-on group lease expired. This is the event that we have enhanced, so this would give us a lot more information. So if you look at the event fields for this event, it gives you the availability group name, the current time, and the new timeout. So when we look at the event in a scenario where a lease timeout has occurred, we will be able to figure out how you were able to track down which event and when the actual issue happened. It also gives you the state. This tells you different states, which is really useful for troubleshooting and whenever you're calling in for support. Then you also get events like automatic failover validation, replica manager when it changes state, when it becomes a secondary from a primary. All of that is really useful. This is again super useful, which is lock redo blocked. This tells you when the redo threads are blocked while trying to acquire a lock. If that's the case, then you will find that your secondary replica is not able to stay up to date with the primary replica because the redo thread is blocked while trying to apply the logged operations against the database. And if any errors have occurred, we obviously don't capture all the errors. You can go through the error list to find out what specific errors are captured. For example, 823, 824, which are related to database consistency issues. So let's see what we are able to find. So the first thing that I will do is I will show you my AlwaysOn configuration. So let me switch over to our primary replica, and if I look at my dashboard, you will see that I have 2 replicas configured. I have both of them set up with one database. There is Tiger AG1, which is my primary replica, and then there's Tiger AG2, which is my secondary replica. Both of them are currently synchronized. I don't have any issues right now. So what I'm going to do is to simulate the lease timeout. I am going to connect to a Windows debugger, and I'm going to pause my SQL Server process, which is the process ID 1700. So once I pause the process, when the lease check comes in, it's not going to be able to find a active connection because the SQL Server process has been paused under a debugger. So the SQL Server process will not be able to respond to the isAlive check, and that would result in a lease timeout. So while that's happening, let me go and show you what would happen if I was able to process all of these events using a Power BI desktop. So if I look at this and I see all these green lines, as I said, the lease timeout happens every 5 seconds. So if I'm running an extended event trace with that lease timeout event being captured, I will see every 5 seconds a green line. And if I see a big white space, that means something went wrong. That's the equivalent of, hey, I was not able to get a response from the SQL Server instance. I don't know what happened. Then obviously you go and check the logs, the AlwaysOn health log. I will talk about another extended event log which gives you a lot of information. So let me go ahead and unpause the process. My current time on my server is 5:22 p.m. and I have an extended event session. So this is my Tiger AZ1 running on the primary. All it does is it captures 2 events, the AlwaysOn group lease expired and the lease renewal. So let's go ahead and capture the new set of events. So I'm going to refresh. I'm going to show you the queries in a short while. But before I do that, I will show you what are the events that this Power BI desktop report can pull up. So let me go ahead and okay, that always happens in a demo. So let me go ahead and restart the demo. Let me pause the process again. And let's see if it's able to refresh this time. So before we started this session, I had initiated a lease timeout. So what I was going to show you is if that new lease expired, what you would see is you would see the availability group name, you would see the time at which the lease expired. You'd see the current time and the new timeout. If the current time is greater than the new timeout, then there's a lease expired, and you would also see the key events which we were capturing. The lease was not valid at that time. Post that, when I stopped the debugger and I allowed the SQL Server process to continue, the lease worker started and it continued without any issues. So from a period of 4:32, you would have seen everything goes wrong, and at 4:35 when everything was back online, I again start seeing the green lines. So let me go ahead and restart the session, and let's see. If my lease works, it is able to work. Again, I see the white space over here. It started the extra sleep. Let me refresh again and see if it's able to bring something up. And let's go ahead and connect to the AlwaysOn dashboard and see if something failed. If it failed over, no, it did not. So there is no failure. It did not fail over anywhere. Now let's go ahead and see how we can track down these using T-SQL queries. So I created the custom XE session. And what I am pulling in to the SQL Server from the SQL Server extended event session is this information. So if I go ahead and execute this in, I basically get my extended event names, and I also get my database name, my replica IDs, which I join on, and I get my replica server names. Once I have that information, I'm able to query the extended event session, which is the AGXE demo, which you saw me stop and start, and I'm getting the timeout information which you were seeing in the SQL Server, in the Power BI desktop window. Now I can open this up in Management Studio as well, and I can look at my data. So I can choose to get this information available in a Power BI window. So once the buffer gets populated, it would show up this information over here. So let's check to see if I am able to refresh my visual again. And for some reason, it doesn't want to play nice today. So I can come back to this at a later time. So let me move over to the next set of extended events.
Hey, man, a couple questions came through that are relevant. One, will the scripts and demos you're going over, will they be accessible on the internet anywhere?
Yes, they would be. I would be uploading the demos and the scripts for all the demos, and along with that, I would also be uploading the Power BI desktop files as well. So is there somewhere specific you want me to share them? I could do that, or I could put them up at a separate location.
Either is fine. You can send them to me, or you put them up on your guys' blog and just shoot me a link. Either one will work, and we'll get that out to everyone.
Okay, great. I will do that. I will share the link with John, and I will update our blog post with the location of the scripts, the Power BI desktop demos as well.
All right, perfect.
Okay, so going on to the latency. So let me go ahead and start a trace on my primary first, a sync trace. I already have another trace running for data movement. Now what I'm going to do is I'm going to insert data into my database, and this is a simple insert. I'm just inserting a few rows. What I want to show is the configuration of this particular extended event trace. So I have all the new events that I talked about. All of those events are added. The capture log block, so if I script out the extended event session into Management Studio, you will see that all the sessions have been added, and one of the important event fields is the processing time. So this is the event field that I was talking about. Every event that I look at has a processing time. So when does the log block flush start? This is the start timestamp, but anything that has to do with processing has a processing time. Anything that signifies a start or a complete would have a start timestamp. So if I look at the log block push, how much time did it take to push it through? If I look at the HADR transport receive log block layer, a message, it tells me how much time did it take to push the log block over to the transport layer. How much time did it take to perform the transport flow control if a flow control kicks in, which in simple words is the throttling. How much time did it take to craft a message and send it over? So that's the processing time. So again, for the receive, which will happen on the secondary, we see how much of time is being spent by the processing time. So this particular event will tell me how long it took for it to receive on the secondary. Then if I look at the HADR LSN send complete, this is how long did it take to send over the complete message. So it gets very, very granular. What you need to remember is all these events process in microseconds, not in milliseconds. So that's a good thing to keep in mind when you're looking at the numbers. So don't get alarmed if you start seeing 5 digits if you're not processing them or dividing them by 1,000. Now, I'm going to go ahead and show you what the actual extended event data looks like. So these are all the commits. What I can actually do is I can group all of these events by adding additional columns. So I can choose columns. I can say processing time. I can choose duration. And then I can group the events by name. And once I do that, if I want to find out how much time is it taking for the HADR to, let's say, complete a flush, so I can see the time frames. Now, if the timestamp shows you the time frame when the message is being recorded, and you will be able to get a timeline of when and why the latency is happening. So once you know the flush is taking time to complete, if you want to find out the why, there is a system health session which runs on the SQL Server instance by default. If you look at the system health session, what it essentially does is it tells you what kind of events were being recorded. So let's go ahead and look at the properties of the health session. So if you want to find out the why, was there a resource-related issue? Was there a problem with my SQL Server instance? Were there errors reported regarding memory failures, or were there any CPU-related bottlenecks? All of that you get here. You get, if you're running CLR objects, you get allocation failures related to your CLR objects. If you have connectivity issues, you will find that the connectivity errors have been recorded for any failed connection. Again, we record some important error messages. If there is a memory-related issue, you would be able to come into these memory-related events and find out if a memory-related issue like an out-of-memory occurred on the SQL Server instance. You even get to see if there were any deadlocks on the scheduler, which means worker threads were not being picked up, which could be a very common reason for latency because there are no worker threads available to process the incoming log records. If there's a wait, you would get to see that. We track multiple waits related to SQL Server, which are commonly known to cause problems based on our experience working with SQL Server customers. We even find out external waits. For example, are you spending time trying to get credentials from the Active Directory? Are you spending time if you're using transparent data encryption with third-party encryption keys? Are you spending time while pulling in the encryption key from your HSM modules? Are there deadlocks? You would get all of this information by default. Now the last one, which is really great, is the SP Server Diagnostic Event. The SP Server Diagnostic Event is able to pull in a lot of information about the system health, which you will see right now. So let me go ahead and pull up the event file for the system health. And if I'm able to group all of this, so let's choose the columns which I want to look at. I want to look at component, look at data, and I want to look at state. So looking at each of these SP Server Diagnostic Events, you would be able to group all of these by name. So these are all the SP Server Diagnostics results. So let's look at each one. For example, let's look at the system. And when you look at the system event, you will be able to see on your SQL Server instance, were there any serious issues that happened, like access violations, write violations? Did you experience any memory dumps during that time? Was there any non-yielding condition where the system was not able to respond? What was your CPU utilization during that time? Did you have any consistency-related issues? And if there were, how many pages were fixed? Because availability groups have the capability of repairing certain pages if they run into consistency issues by pulling them from the other replicas. So all of this gets tracked by default. If you look at some other component, for example, if you look at the resource component, now this is really good because it gives you a quick snapshot of what your system's health looked like at that time. How much of physical memory was available, what was your working set consumption. If it's 100, it's really good. Then you are able to find out how was your memory usage. Was your physical memory usage very high? Was your physical memory usage very low? Were you experiencing any memory pressure? And if you look at your memory-related DMVs, the more critical ones are provided here. How many lock pages are you using? What's your current committed target? And how many pages have you consumed from that current target? What's your factor, which tells you whether there was an out of memory. If it's 0, you're good, so I don't have a problem on the system right now. There's another component called query processing, which gives you some really great information about how many waits you're experiencing. So because the only thing that I'm running on my SQL Server instance is availability groups, and I'm running stress kind of demos on them, you will see that the highest waits are associated with HADR, and it also gives me how many waits have occurred for that particular snapshot, what was the average wait time, and what was the maximum wait time. And if I look at my max workers and idle threads, this will give you a good indication of whether my SQL Server worker threads are able to keep up with the workload that's coming in. So if I look at all of this data, you will see that I've got 512 worker threads, I've got 62 workers currently created, and I don't have any pending tasks, which tells me my system is actually doing very, very good. Now, I also would be able to find out the weights by duration. These were weights by counts, the top half of the XML. The second half of the XML node gives you all the weights by duration. If you can compare two snapshots, you would be able to figure out what was the delta between two different time snapshots. Between, if you capture at T1 and T2, if you subtract the two, you would get how many waits occurred between those two timestamps. And the last one that I'm going to talk about is IO Subsystem, the IO Subsystem component. The IO Subsystem component is interesting because right now I don't have any IO related issues, but if I did, I would see the long IOs, and I will also get information about which of the files experience the long IO request. So if I do find that there is a latency by going back to my, let me close down this event. If I go back to these set of extended events, if I find that there is an actual latency, I can actually go back and correlate with the SQL Server system health session really quick to find out at a high level if I am able to identify what was the system bottleneck at that time. If there is a blocking scenario, the system health session will be able to show you that to you in terms of weights. And the query processing component also gives you a lot of information about the long blocking chains and information about long-running queries. So right now I don't have either, which is why the query processing component did not provide that information to me. But if there was, the XML node would have an additional tag which gives you the long-running queries and the block queries. So, John, do we have any additional questions?
Yes, I have a few that have popped in here. So with the new extended events, does this cover all possible pass into code for message being sent from primary to secondary, or just some well-known troublesome areas?
It captures, the question was, does it capture all possible transitions of a message from the primary to the secondary and back? Yes, it does, which is why we're not shipping this as a default, always on trace configured. What we're doing is we're giving you these set of extended events, and we're giving you the configuration parameters along with the Power BI desktop report. So it's to be used only when you're troubleshooting perf-related issues associated with latency. Do not have these turned on by default because this captures each and every state, and running this continuously in production is going to generate a lot of X7 data.
Gotcha. That ties in very well with the next question. When running multiple extended event traces in production, what kind of expected overhead would you see with the events that you're looking at today?
Okay, so let's talk one by one. So if I talk about the availability group extended event demo session, which was capturing the lease timeout and the lease renewal, the lease renewal is very chatty. So when you're configuring the extended event session, so let's look at the session properties. So when you look at the session properties, you will see that for now, I don't have any kind of rollover capabilities, but when you're configuring the event, you can choose in your targets to have a rollover capability. If you look at data storage, you will see a ring buffer target, and under the ring buffer target, you can specify the amount of memory. Right now the session's running, which is why it's grayed out, but if it was not running, it would let you change the maximum buffer, which you can keep. We also have a ring buffer entry for this so that you don't have to track it by default. I don't recommend running the lease renewal XC event continuously unless you're troubleshooting some specific issue, because the system ring buffer information captures the lease timeout. But the lease expired event, that's already part of your always-on health trace that runs on every instance that has availability groups configured, so there is no performance impact to that. For the other set of extended events that I was tracking, the data movement, as I said, there is an overhead because you have to log each and every transition of that message into the SQL Server extended event trace. So I would not recommend that running continuously. I would only turn that on when I'm troubleshooting latency-related issues. It's good to have it configured as a template on the system. Any other questions, John?
Pretty sure I know the answer to this next one, but I'll throw it over to you anyway. Will any of this be available through PowerShell commandlets?
That's a good question. As of now, the only thing you can do is use PowerShell to run the T-SQL scripts. We do not have any plans at this moment to put this into PowerShell commandlets, but that's good feedback. You know, whoever put that in as a question, I would recommend them to go into Connect and file that as a feedback item. And if we see a definite uptake in the number of votes, we would consider that as good product feedback and evaluate the possibility of doing that.
Great.
Okay. So going back to my session, so let me switch over. Now, all these extended event data that I'm showing over here, that doesn't look nice. Let me zoom back out. If I have to look at each of these messages, at times it's going to be difficult. So what we did in, let me go back to my window. So what we did over here is we created an extended event pulled from the Power BI desktop again, and this gives you a latency. I'll just explain quickly the different sections. So the first one shows me my primary replica commit time. So over a period of time, depending on when I was pushing in the data, and this is what I kicked off before I started this session, you would see the processing time increase. So the time it took for the primary replica to commit increased. So I'm able to track that. So then if that's the case, then I will go and look at the system health session on my primary replica, and I will try and figure out the amount of time it took for the commit. So what I would be looking for in the system health session is the SP server diagnostics outputs, and I will look for write log waits. I would look for the scheduling, the scheduler health, and I would see if there were pending tasks or any worker threads that were not able to process requests, because I would get to see how many pending tasks were there. I would also get to see how many workers are created as opposed to the number of workers available. So that would tell me if I have a latency issue because I'm not able to process my logged operations as fast enough as I would like to on the primary replica. This tells me primary replica remote harden time. So this essentially tells me how long it took for me to receive an acknowledgement for remote harden. So the reason I'm tracking this from the primary replica is because I could have more than one secondary replica, so it's good to know how long the primary replica waited for the commit to happen. Both my replicas are configured the exact same way, so with the exact same workload. So if something was taking time to commit here, I can see an exact peak happening on the other side as well. So it took some time to commit there. Again, the processing time shows me how long it took. The secondary replica apply time. This is my the graph in the second quadrant, which I'm highlighting, which is secondary replica apply time. This tells me how long it was taking for the secondary replica to apply the messages that it was receiving. And I can see that it slowly declines over a period of time as the workload decreases. So, and this I've been tracking for a large number of days. So I did not have anything running at that period of time, so I don't see any issues. Now, at the bottom half of the screen, you will see tiles which show me commit time in microseconds. So it tells me my commit time and my remote harden time are pretty much the same. It takes me a very, very small amount of time to do compression and decompression. Decompression happens in the secondary. The apply time is very, very low, and the receive time, which is the time it took on the secondary replica to receive a message from the primary replica, is also very low. So now I can safely say I don't have any latency on the network. I don't have a problem sending message across or receiving messages from the primary or the secondary. What is taking time is essentially working through all those transactions at the pace that's being generated by the application, in which case, in this case, it's the Management Studio. Let's quickly look at the send time now. On the right, you would see the send time, and you would see the secondary replica send time. So it tells me that my primary replica sends messages much faster than my secondary replica. And let's quickly see how each of these files are configured. So the commit time is configured using recovery unit harden log timestamp. So it tells me how much time it takes to harden the log records. The remote harden is the HADR DB commit manager harden. So that tells me how long it took to harden on the secondary. This is a group commit. So if this was a new feature introduced for group commit, so unless you see a group commit on your transaction log, you will not need to be concerned with this particular wait. But sometimes group commits can be a source of problem when you're doing a lot of parallel transactions and flushing a lot of log blocks within a very short span of time. The compression is tracked using HADR log block compression, pretty self-explanatory. The apply time is tracked by HADR apply log block, and all of these events I am using processing time. So all those set of events that I showed you on my PowerPoint slide, I track them down by the scenario and the message that they signify. And I'm only using a very specific set of events to build this entire picture. The decompression is tracked by HADR log block decompression, and the receive time is tracked by the secondary receive time. So that's the data that's used to build this dashboard. We have also added Perfmon events. So let's go look at those. So the Perfmon events that are present in SQL Server 2012 Service Pack 3 and Service Pack 4. So the counter names are group commit time, which gives you the number of group commits happening per second, and the number of the amount of time it takes to do group commit, how many compressions are you doing, if there is any flow control. This helps you determine if there is flow control happening on the database. If you have transparent database encryption enabled, so how many encryption IOs are happening, this helps you track that as well. So let's go and look at the output for both. So if you are able to look at the event, the object name is database replica, the counter names as group commit time, and all of these show up per database replica. So let me switch to grid. And all of them show by instance name. The instance name here is the database which is part of the availability group. So it tells me that because I am sending in a lot of data, it's able to compress a large number of log blocks. And when I showed you the dashboard, you would see that these events are not a source of latency because the compression and the decompression is happening really quick. But these are, again, good Perfmon counters. Perfmon counters are able to give you a good feel of the overall performance without having to turn on these extended event traces. Any more questions, John?
Yes, I guess one question that popped in, if you have multiple secondary replicas, is there an easy way from Power BI to determine the latency between each one of the secondaries?
Good question. So let me show you the fields that are there. So I am pulling in data from each of the secondary replicas. So if I have to pull in events from the secondary replicas, what I'm actually doing is, let me show you my query. So this is the data that is coming in for me. If I look at my replica events, this is all the data that's coming in. What I would need to do is I would need to do a get data from SQL Server. The extended event trace needs to be run on each and every replica, and you will need to pull in that data into the Power BI, and all you need to do is move this over, copy paste another secondary replica window over here, and you would need to change the connection. Right now this is pointing to the one highlighted in yellow. You would need to change that to the new data set that's been pulled in. So it's pretty simple to add that. And what you would need to do on your additional secondary replica, so this is my secondary replica, I have a AlwaysOn data movement tracing extended event running there. You would need to create the same extended event trace on the additional secondary replica that you have.
Great. And just to repeat, a couple people have asked this, so I'll mention it, that Amit will share the scripts in the Power BI dashboard that he has as well.
Okay. Great. So I'm going to attempt the demo again. So if that doesn't work, then definitely the demo gods are not happy. And what you know, right now it worked. It opened up fine. So let me try and see if I can pull in the data. Seems to be connecting fine. So while it's doing this, what I wanted to talk about was these two Power BI desktop reports that I share would be useful currently, and what we're evaluating right now is we're checking how we can make this more visible in the different tools that you use. So these events we have found have helped us troubleshoot a number of customer issues in the past on SQL Server 2012 Service Pack 3, and once we ship them in Service Pack 2 for 2014, they're going to be helpful in these scenarios as well. So I would love to hear your feedback on these, and if you want to drop us a note, do send us a tweet at MS SQL Tiger, or send us a feedback on Connect, or even post on the recording of this session, which is going to go live on YouTube anywhere. We're more than happy to get feedback, and if you have any ideas for improvement that you would like to see, like PowerShell commandlets, file a connect item, we really appreciate customers taking the time to give us feedback to improve the product. So yeah, for now, this worked. So if I had to look at the demo again, and if I had to break in using a debugger, and probably this is going to work. So what this does is the white space that you see right now, it did not have data from that prior period. So if you're not seeing an expired lease at the bottom, nothing went wrong. It just means that the extended event session was not running during that time. But if you see a white space when the event was running, you would see an expired lease event entry here. So let me go ahead and continue. And let's see if it's able to figure out lease timeout. So I can see it picked up one lease timeout, and it's processing the additional entries, and there you see the lease timeout. So I can see at 5:58 p.m. my time is 5:59. At 5:58 the lease timeout happened. Again, the current time is greater than the new timeout, which is why the lease expired, and I can see it right at the top over here. If I were to decrease the time filter, for example, if I went there and said don't show me anything from all of these times.
And then, Amit, is there a good way for you to see whether the timeout is from the Windows failover cluster side or the SQL execute side?
Okay, good question. So let's go ahead and look at the SQL Server instance. So essentially, this is where collating the logs can be a challenge, but what we actually do is we have these extended event sessions, and if you haven't used them, might be a good idea to go back and check in your availability group environments for these SQL Diag sessions. This is not the AlwaysOn or the system health session. There are SQL Diag sessions which you can open up in Management Studio. So when you open up these extended event sessions, you will see that you get a lot of good information. Let me do a grouping and show you what you can find. You will get the availability group state change. It tells you whether the system's unhealthy or not. You can also see info messages, which are useful, and this is what will help you track down what's happening for that particular replica. So I get the instance name, I get the node name, and I also get information like, oh, you see, there's a connectivity failure. So, and that's around the time that I had the issue, which is 5:58. And you can see the ODBC failure because the Windows cluster was not able to connect because a debugger session had, I used a debugger session to stop or pause the SQL Server process. I broke into the SQL Server process. So the SQL Server instance was not responding to the cluster. And I get all of that information right there in my Management Studio from the SQL Diag event. So health worker was asked to terminate. And then you get the availability group is a live failure. You see lease expired right at that time. And what's useful at that time is the component health results. So let me add some more columns. So you get to see the component health results. You get to see the data from the AG, and you get to see all the additional system health sessions, and you also get to see the set of events that led up to the issue. So you get to see the ring buffer recorded. We can write T-SQL queries to process these extended event data points. John, does that help answer the question?
Yep, no, it definitely does. Yeah, I'm a big fan of SQL Diag XEvent. I've used it quite a few times with root cause analysis myself.
Great. So yeah, just to finish on that point, so you are able to get from a point where you know a lease timeout happened all the way to a possible root cause from right within Management Studio. There are multiple extended event traces that are running on the system health session, the AlwaysOn health, and the SQL Diag, which helps you troubleshoot a bunch of these issues. And as John said, this has helped him multiple times in the past. So once again, thank you for attending. We love to hear feedback from our customers. This is our blog where we announce all the improvements that we ship, and our Twitter handle. Feel free to reach out to us. Over to you, John.
All right, thanks, Amit. Greatly appreciate you coming out and presenting some of the new things coming down the line in the service packs. Also, we'll meet again next month. Alan Hurt's going to be talking about new enhancements with HA features of 2016 next month, and we'll catch you all then. All right, I'm going to go ahead and close out the webinar, and we'll see everyone next month.